Taps 4 inches or 100 millimeters in diameter and larger are made by connecting a flanged tapping sleeve to the pipe either with straps or a halfback. The process is larger, but similar to the process for making threaded outlet taps. The tapping saddle includes a gland with a rubber gasket that will provide a watertight seal against the pipe cylinder. Also, note that such larger saddles include a foam seal around the perimeter of the saddle. That seal will allow a mortar grout to be poured to fill any gaps between the saddle and the pipe's exterior mortar coating. To begin, identify the tap location on the pipe away from the pipe joint so that the foam seal will be effective. Mark the area for mortar and wire removal to be slightly larger than the base of the tapping assembly gland. Chip away mortar coating either before attaching the tapping saddle or after, as shown in this video. Position the tapping assembly saddle over the opening or marking on the pipe coating and secure it to the pipe with straps or clamp-style halfback. Take care to not damage the foam seal grout gaskets. Tighten the bolts with only sufficient torque to lightly seal the grout gaskets against the pipe. Fill the space between the pipe and saddle and between the pipe and halfback, if applicable, completely by pouring a quick-set Portland cement mortar into the holes provided. Allow mortar to harden before proceeding to the next step. This mortar assures the saddle will immediately reinforce the pipe cylinder when the reinforcing bars or pre-stressing wires are cut. Once the quick-set mortar has hardened, tighten the bolts to 80 to 90 foot-pounds of torque. Chip away mortar coating from an area slightly larger than the base of the tapping assembly gland. This exposes the steel cylinder and helical wire or bar on either lined cylinder pre-stressed pipe or bar-wrapped steel cylinder pipe. On embedded cylinder pre-stressed pipe, the helical wire and exterior concrete core will be exposed. Prior to cutting wires on larger taps, check with pipe manufacturer for maximum allowable pressure in the exposed cylinder. Chip all remaining mortar, cut and remove wires or bars from inside the opening in the mortar coating and tapping saddle. This exposes the steel cylinder on either lined cylinder pre-stressed pipe or bar-wrapped steel cylinder pipe. For embedded cylinder pre-stressed pipe, removing the wire exposes the exterior of the pipe's concrete core. The exterior concrete core must be removed within the tapping saddle hole so the pipe cylinder is exposed. Check to assure the gland gasket is clean and in the gland's gasket groove. If there is a weld seam on the cylinder of the pipe in the area of the tap, carefully flatten the weld so that the tapping sleeve will seal on it, but do not grind the weld. Connect the gland flange to the saddle and secure it with stud bolts inserted into the saddle flange. Tighten the anchoring nuts to compress the gland gasket against the pipe steel cylinder for a watertight seal. Check the position and compression of the gasket against the steel cylinder using a feeler gauge. There should be approximately 1/8 of an inch between the gland and the pipe cylinder. After installation of the tapping gland, tighten the load-bearing set screws located between the draw bolts of the outer bolt circle. This locks the gland in place and transfers any loading from the outlet onto the sleeve and away from the cylinder. Connect a standard tapping valve to the gland flange with valve studs and/or cap screws. Position a support under the valve so the valve weight is not supported by the tapping saddle. The power-operated tapping machine with shell cutter is brought into position. You can see the pilot drill in the center, which will penetrate the pipe wall first and stabilize the shell cutter when it cuts. The tapping machine is connected to the tapping valve flange with the valve closed. Once the connection is complete, the entire connection and rubber seal against the cylinder is tested for water tightness by opening the valve, injecting water at a pressure not exceeding the internal pressure of the pipeline, and assuring a constant pressure is held. Once water tightness is proven, the tapping valve is fully opened and the tapping machine pilot drill is advanced to begin cutting the pipe wall. The cut is complete when the pilot drill and shell cutter have advanced a predetermined distance as shown on the travel indicator. When the cut is complete, the shell cutter is withdrawn back behind the tapping valve and the valve is closed. The tapping machine with shell cutter is then disconnected from the tapping valve. The tapping saddle must now be protected from corrosion. With the aid of a joint wrapper, apply a protective coating of Portland cement mortar at least 1 inch or 25 millimeters thick over all exposed surfaces of the tapping assembly, including the halfback or straps, and filling the annular space between the gland and the saddle pipe. Also, assure permanent support under the tapping valve. This completes the flanged outlet tap. Concrete pressure pipe is routinely tapped all across North America. For more information, contact your local concrete pressure pipe supplier or at www.acppa.org.